Hello, everybody. We are in Unit 1. This is lesson number 2, titled Learning Targets Length. Please make sure that you have the note sheet in front of you so that you can follow along and participate. If for some reason you do not have your copy anymore, then go onto your teacher's School Fusion page and print off a copy so that you can participate with us. What we're going to talk about today is how to find line segments and the length of those line segments, whether it is on a graph or if you're given a set of points. We're going to go ahead and start by talking about some notation so we can understand what all these symbols and words are referring to. Remember, notation just means math language, a way that something is represented in math. So looking at number 1, we see the letters AC with a bar across the top. What this represents is a line segment. All right, so let's go ahead and draw a diagram so we know what a line segment looks like, and we're going to describe it. All right, a line segment is pretty much a chunk or a piece of a line. It has 2 endpoints, so it has a definite start and beginning. All right, so at home, we're going to draw 2 points, A and C, and make sure you are using a ruler or a straight edge of some sort to connect those points. All right, I'm going to use my handy dandy line segment tool just because I can. Okay, yours should look something like mine. All right, let's go ahead and describe it. Well, we said that it was a chunk of a line, a piece of it. So we'll say a piece of a line. And it has 2 endpoints, meaning it has a start and a stop. All right, and that is our line segment. All right, take a second to look at number 2, notation AC. Think in your mind right now, what is the difference between the way number 1 is written and number 2? If you recognize the fact that there is no bar across the top number 2, you are correct. That is the difference, and it means something different. All right, so when you do not have a bar across the top, this is referring to the length of a line segment. Super important, is referring to the length. AC is always a number. All right, so we need to remember the difference between the two. So let's take a second and let's explain it. Well, we said that when we have the bar across the top, that's referring to a line segment. So think of it this way. It's always referring to an object, an actual thing. Okay, a line segment, we can also put something across the top and draw rays, we can draw lines, whatever. But when there's a symbol across the top, it's referring to an object. In this specific case, a line segment. When there is no bar across the top, that is referring to the length of the object that you are looking at. It is always a number. As we go on through this unit, you are going to be given just symbols and you are expected to know, is it referring to the object or is it asking me to find the length? All right, so we need to be comfortable with this information. All right, let's take a look at number 4. Prerequisite knowledge. Remember, prerequisite knowledge is things that you have learned in the past and we're trying to help remember to help us with our new concepts. Okay, so our directions tell us to use the diagram at the right to answer the following questions. Question A says, what is AC? Now notice, it can look a little confusing, but there is no bar across the top. So since there is no bar, this question is really asking us, what is the length? Let's make a note of that so that we can help us later. What is the length of AC? Okay, so we can go ahead and go on this diagram. It's nice because it's actually already drawn for us. And to find the length from A to C, all we have to do, sorry, I'm not good at the brackets, all we have to do is count the boxes between A and C. So we have 1, 2, 3, 4, 5, 6, 7, 8. So the length of AC is 8. All right. Letter B says, what is CB? Once again, there is no bar across the top, so it's asking us for the length of this segment. So we can come down here and count the boxes. 1, 2, 3, 4, 5, 6. All right, the next part asks us to draw line segment AB. So we're just going to use our straight edge at home, and we are going to connect those 2 points. I'm going to go ahead and use my straight edge tool once again, or my line segment tool, I should say. And I'm going to connect my 2 points to make sure it's as straight as I possibly can get it. Perfect. Okay. Now, before we go on to the next, one thing to notice. We are learning how to find the length of segments that may not be directly in boxes. If you notice the difference between AC and CB, they line across boxes perfectly, versus AB is on a diagonal. We can't count whole entire boxes, so that's why we are using this method. All right, so letter C, we drew it. What kind of triangle is triangle ABC? If you said a right triangle, you are correct. Okay, because this forms a right triangle. When you have 2 straight lines on our coordinate plane grid, they form a right triangle. So right triangle. For that kind of triangle, what are AC and CB called? So now referring to the sides of the triangle. What do we call those 2 sides that form the right angle? Those are called the legs. And remember, this is all prerequisite knowledge, so it's stored somewhere in that brain. We just got to pull it out. Okay, so we got a right triangle. We have our legs. Now, what is that other side called? The side that's always across from, hold on. Sorry about that. All right, we're looking at the side that is always across from, directly across from the right angle. That is called your hypotenuse. Hypotenuse. That's how I remember how to spell it. Okay. So we have a right triangle, we have a hypotenuse, we have the legs. What theorem have you guys used in the past to find the length of the hypotenuse if you know the other 2 pieces of information? If you said the Pythagorean theorem, you are correct. And if you recall, this is the equation for it. A squared plus B squared equals C squared. All right, so we are going to plug in our information. A and B always represent the legs. C always represents your hypotenuse. So for this, we're always going to know our legs. Okay, so keep that in mind. So we're going to sub A in, or 8 in for A. So we'll have 8 squared. We're going to sub 6 in for B. And we are finding C, which in this case, we are finding AB. Okay? So we're going to do AB squared, because that's what we're finding. So we'll go ahead and do the math. 8 squared is 64. 6 squared is 36. Go ahead and add those 2 together. You get 100 is equal to AB squared. All right. Now from here, remember, if AB is squared, to undo it, we're going to take the square root. And the square root of 100 is 10. So that tells us that AB has a length of 10. Let's move on. Okay, so now, sorry about that. In our previous example, we were given the 2 legs and we drew our hypotenuse and found the length. Well, if you notice in number 5, we're actually given the line that we are finding the length for. Okay, our directions say if 2 points are graphed, find the length of the segment. Now, we're not going to sit here and use a ruler and measure it and say, oh, it's, 5 millimeters, whatever. Okay, we have to find the actual length, and we're going to use our Pythagorean theorem to help us. So, it's on a diagonal, we can't just count. Keep in mind, our Pythagorean theorem is always used when you are using right triangles. So in order to do this, the first thing we have to do is we have to create a right triangle. That's step number 1. How do we do that? Well, we can draw it on our graph. Okay, so what we want to do is from A, we want to draw a vertical line straight up until you get to where B is going to be. And then we are going to connect that over to B. I apologize, mine is a little bit off. We get the point. Okay, so I draw a line straight up and then over. That creates my right triangle. Now what I need to do is I need to find the length of each segment. All right, so here I have 1, 2, 3, 4. Yes, that's supposed to be a full box right there. Going over to B, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If it helps you to make little tick marks to ensure that you are counting properly, please do so. Okay, and now we can just go ahead and do what we did on the first page. We'll use our Pythagorean theorem. So we created that right triangle. All right, so my two leg lengths are 4 and 10. And we are finding AB. Okay, so we'll go ahead and do our math. 4 squared is 16. 10 squared is 100. So we get AB squared is 116. Now in our first example, when we got to this step, the number that AB squared was equal to was a perfect square. So we were able to get a whole number answer. In this case, 116 is not a perfect square. So there are 3 different ways that we will accept an answer from you. You can start by just taking the square root and leaving it as the square root of 116. We will accept that. We will also accept if you simplify the radical. Okay, pulling out perfect squares and taking their square roots. This one would simplify into 2 radical 29. If you do not know how I got that, then please bring your question to class and ask your teacher, or leave your answer in a different form. We will also accept if you type this into your calculator, the square root of 116, and get a decimal answer. Answers must be 3 places out and do not round. Just cut it off at 3. Okay, so all 3 of those numbers are equivalent to each other, and all of those answers would be accepted. Alrighty, number 5 is a you try. So what I would like for you to do is to pause this video and go ahead and try this problem on your own. Okay, so take a look at our answers right here. Your answer should match mine, and remember, it does not matter if you use the answer as the square root of 13 or if you leave it in decimal form. We will accept either. If your answer does not match, pause the video again and see if you can go back and find your mistakes. Make sure you are drawing the triangle on your coordinate plane. All right, let's take a look at another method in order to find the length of a line segment. So if you notice in example 6, this time we are given 2 points, but we are not given a grid or coordinate plane to help us find the length of the hypotenuse. So what we